So in this problem, it actually gives us a function t of x and y and z. X and y and z is a point in the space, and t gives the temperature at x and y and z in degrees Celsius. And basically, it gives the value t sub x at that point, which is 2, and then t sub y at the point 2, 3, 4, and t sub z at that point over here. And so it's asking in which direction does the temperature increase fastest at 2 and 3 and 4. So when we're giving the direction, it doesn't of the fastest increase, we know that the gradient is the direction of the fastest increase. Gradient of t at point 2, 3, and 4 is exactly 2. So if you remember, it's t sub x at the point, t sub y at the point, and t sub z at the point. And that is 2, 10, and negative 10. So this is the direction of fastest increase. The direction of fastest decrease is the negative of this. You can either keep it as that or find the magnitude of the gradient of t at 2, 3, and 4, which is going to be square root of 4 plus 100. I apologize. This should be 11 as it's there. Plus 121, and that is 15. And so you can either give that direction or you can give the unit direction. Oh, 2, 3, and 4 unit, which is going to be 2 over 15, 10 over 15, negative 11 over 15. Either one is acceptable. Now, the second question is asking, at what rate does the temperature increase fastest? And so to find this, basically, what all it says is that this was the direction, right? 2, 10, and negative 11. And the rate of increase, the fastest increase is going to be equal to gradient, magnitude of gradient of t at that point. And that is, we computed, was 50. It's actually, this one comes from the fact that gradient of t dot any u is maximum when u and gradient of t are in the same direction. And that is when theta is equal to 0. And then basically the rate is going to be gradient of t dot gradient of t divided by magnitude of gradient of t, and the magnitude of that entire thing. And that's how we get it here. So this part was just the explanation of why these two are true. The next thing is asking, find the directional derivative of t at this point in the direction given by that direction. So now that I'm finding directional derivative, I have to basically make sure that the direction is a unit vector. This is the direction in which I'm finding the directional derivative. I have to make sure that that is given in the, so I have to find the magnitude of negative 1, 2, and 2, which is square root of 1 plus 4 plus 4, which is 3. And then divided by the unit direction, which is -1/3, 2/3, and 2/3. Then dot that with the gradient. Gradient is coming from here. So 2, 10, and -11 dot. So d sub u of t at 2, 3, 4, and dot of the unit vector 1/3, 2/3, and 2/3. And the answer is going to be -2/3 plus 20/3 minus 22/3, which is -2/3